Example 2. Solve each inequality, graph each solution. Letter A, 5 is less than or equal to m plus 4, which is less than 10. Now, this is a compound inequality. You see two inequalities. My first question is this an and or is this an or? And the answer to this would be it's an and because it's written with one statement in the middle. If it's an or, you physically have to use the word or. So this is an and statement. The way we deal with and statements, you're first going to consider your left-hand side. Just kind of like knock that out. And over here, we're going to write 5 is less than or equal to m plus 4. We said it was an and statement. So now we're going to break it and say and your other statement, now we consider the right side, and you have m plus 4 is less than 10. So those are actually the two statements that went into writing it as this compound inequality. Now we're going to solve each one. So I'm trying to isolate the m. I'm going to subtract 4 from both sides. 5 minus 4 is 1. I didn't multiply or divide by any negatives, so I keep my inequality the same. And that's going to give me m is greater than or equal to 1. Then I'm going to go do the same thing over here. I'm going to subtract my 4. M is less than 6. That's your solution. Now it says we have to graph it. So we have a 1, we have a 6. So let's say we put 1, 2, 3, 4, 5, 6, and then we could keep going. M is greater than or equal to 1. So at 1, I'm going to put a closed dot, and I'm going to shade greater than. M is less than 6, so I'm going to put an open dot, and I'm going to shade less than. And then because this compound inequality is an and, I'm looking for an intersection where they both exist. So my actual solution is going to be where the blue and the red both are. So I'm going to shade this in yellow. So graphically, the solution is the yellow, and then using symbols, your solution is the blue. Letter B, -3 is less than 2k minus 5, which is less than 7. Very similar to the last one. Again, because it's written as one compound inequality, this is an and statement. So we're first going to break it, and I'm going to consider the left. So we have -3 is less than 2k minus 5. And then I'm going to look at the right. 2k minus 5 is less than 7. And then I forgot, don't forget your and, because your solution has to be both. Over on the left, I'm going to add 5. -3 plus 5 is a +2, less than 2k. Divide by 2. 1 is less than k. That's your first solution. Let's go solve the other one. Add 5. 2k is less than 7, 8, 9, 10, 11, 12. Divide by 2. K is less than 6. Then we're going to take a look at what that looks like graphically. So k is greater than, we've got a 1, we've got a 6. So 1, 2, 3, 4, 5, 6. And again, I could keep going. But k is greater than 1. So open dot, shading to the right. K is less than 6. Again, open dot, shading to the left. and then and, so find their intersection. We would have to be greater than 1, and we would have to be less than 6. So graphically, your solution is right there. It's the yellow part, and then algebraically, that would be your solution. Letter C. 4c plus 3 is less than and equal to negative 5, or c minus 8 is greater than negative 1. Now notice the difference here. This time they specifically wrote or, which means this is not an intersection, this is a union. When you solve a union, you just solve each individual inequality. So I'm going to start with 4c plus 3 is less than or equal to negative 5. I'm going to subtract 3. 4c is less than or equal to negative 8. Divide by 4. Now, notice we're just dividing by positive 4, so we don't have to flip any signs, but negative 8 divided by 4 is negative 2. Or, on this one, I'm going to add 8, which is going to leave me with c is greater than 7. So I have a negative 2, I have a 7. Let's see, if I put negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. Oh, I'm going to have to move this down. Negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7. My first one is c is less than or equal to negative 2. So close dot, less than, shading to the left. C is greater than 7, open dot, shading to the right. And notice this time there's no overlap. So your solution is either down here in the red or up here in the blue. So graphically, your solution is both of these, and then algebraically, your solution would be written like that. Letter D. 2p plus 1 is less than negative 7, or 3 minus 2p is less than or equal to negative 1. Again, they're using the word or, so we're talking about a union. We just solve them separately. Subtract 1. 2p is less than negative 8. Divide by 2. So p is less than negative 4. Now again, I did not switch that inequality sign because I divided by a positive 2. 8 was already negative. That's not what I was dividing by. Or, this time, I have a negative 2p. I'm trying to get rid of a positive 3. The opposite of positive 3 is minus 3. Now, the 3 goes away, but this is still a negative 2p. So, negative 2p is less than or equal to negative 4. Now I'm going to divide by negative 2. This time, you are dividing by a negative. This was a positive 2, this is a negative 2. And remember, if you multiply or divide by a negative, you have to flip the inequality sign. So we're going to flip it to, excuse me, greater than or equal to, and then a negative divided by a negative is a positive, so positive 2. On our number line, we have a negative 4, we have a positive 2. So I'm going to go negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and then I could keep going. P is less than negative 4, so negative 4, open dot, shading to the left. P is greater than or equal to positive 2, so close dot, shading to the right. And again, because it's an or statement, we are either down in the red zone or up in the green zone. Any of these numbers would be our solution. And then algebraically, you can just write your solution like that.